The French mathematician Blaise Pascal invented the calculating machine called the Pascaline in the early 1640s. More than 50 prototypes were created, with widely varying designs. The explanation given here follows the basic design of the 9 machines that are still in existence. The operation of the Pascaline will be shown first, and then the mechanical design will be presented. On the top of the calculator is a series of input dials and output windows. Each input dial is divided into 10 parts by a set of spokes. A digit is entered into the machine by placing a stylus between the appropriate spokes and rotating the wheel clockwise until a metal stop is reached. Entering several numbers consecutively causes their sum to be displayed in the output windows. The values stored in the Pascaline must be cleared before a new series of additions can be performed. Clearing is done by setting all the accumulators to 9 and then adding 1 to the lowest order digit. Setting each accumulator to 9 can be accomplished by inserting the stylus between 2 specially marked spokes and turning the input dial all the way to the metal stop. Adding 1 to the lowest order digit causes a carry to ripple all the way down the machine, and zeros appear in every output window. You cannot perform subtraction directly on the Pascaline because the input dials only rotate in the clockwise direction. Instead, subtraction is performed indirectly by using a trick known as nines complement arithmetic. The nines complement of any one-digit number is 9 minus that number. For example, the nines complement of 6 is 9 minus 6 equals 3. In a calculator with n dials, the nines complement of a number a is 10 raised to the nth power minus 1 minus a. And therefore, the nines complement of a minus b is 10 to the nth power minus 1 minus a minus b, which is equal to 10 to the nth power minus 1 minus a plus b, which is equal to the nines complement of a plus b. The output drums of the Pascaline actually show each digit and its nines complement, but a sliding display bar is used to cover one or the other. To subtract two numbers on the Pascaline, you must first slide the display bar down to uncover the nines complement values, and then enter the nines complement of the menu end. If you do not have the nines complement of each digit memorized, you can simply place the stylus between the specially marked spokes and rotate clockwise until the stylus is aligned with the digit you wish to enter. The subtrahend is then entered in the normal fashion. The correct result is now displayed in the output windows. Because our inputs were only 2 digits long, we only consider the lowest 2 digits of the output. Looking inside the Pascaline, we see 5 sets of nearly identical mechanisms. A pair of crown wheels transfers the rotation of the input dial to an accumulator wheel. A backstop pawl meshes with the accumulator to prevent counterclockwise rotation of the input dials. The value stored in the accumulator is transferred by a pinion wheel to an output drum, which displays the value through the output window. The carry mechanism consists of two pins mounted on the back of the accumulator, a heavily weighted lever mounted on the axle of the accumulator belonging to the next higher order digit, and a spring-loaded pawl. The two pins are located in such a way as to engage a fork on the carry lever and lift it upwards as the accumulator advances towards the value 9. As the carry lever rises upwards, the carry pawl also rises, and its spring causes it to maintain contact with the pins on the face of the higher order accumulator. When the lower order accumulator advances from 9 to 0, the heavily weighted carry lever falls back to its resting place with enough force to cause the spring-loaded pawl to engage the higher order accumulator and advance it by 1 digit. The carry operation is shown here in slow motion. In the actual machine, the carry operation happens almost instantaneously. In this final sequence, we repeat the earlier example of 28 plus 35 with the internal mechanisms exposed.